We will now introduce some basic concepts that allow us to analyze not just the plain vanilla swap, but in fact most simple interest rate swaps, basis swaps, and the like. So what we need to introduce first in order to look at a swap is the fixed rate. We'll give that a short name. Let's, in the following slides, use capital K as the name of the fixed rate. We also need to look at the two legs, so we need to look at accrual fractions or coverage for each of the two legs. And as we have covered before, they may in fact be different for each individual payment. And they may also be different for the floating leg and the fixed leg. So for the ith payment, we'll denote by a Greek delta letter here the coverage for the ith period for the fixed leg, and similarly we'll denote by delta float the coverage for period I for the floating leg. There are a couple of reasons why they can be different. It can be the length of the individual periods, it can be the conventions, and a few other things. To generalize our results, we also need to consider a notional schedule or set of notional levels for each and every single period. So we could denote by capital Ni the notional level for the ith period. For looking at everything that is interesting for the plain vanilla swap, we need essentially only 4 numbers. And these 4 numbers or concepts we'll introduce now. So if we think of the payment schedule or cash flow structure of, say, the fixed leg, we have a sequence of dates. And on the fixed leg, we will receive a fixed rate. Let's look at this guy. So on this date, we'll receive the fixed rate proportionate to the length of the period. So that was the delta fixed for period I, multiplied by the notional for that period. So that's the period ending here. Let's call that the ith period. So the coverage measure the distance, the K is the rate, the N is the level of the notional. So we will have one of them for each of the periods for the fixed leg of the swap. So the first thing we will care about is what is the present value of the fixed leg at time t. So think of t as some time before the swap starts, maybe the trading date. And we'll use simple mathematical notation. Think of it as the sum 0, 1, all the way up to n minus 1 are the coverage for the fixed leg, the notional for that period, the fixed rate itself, and since all of these are known fixed payment in the futures, it is okay just to discount them back corresponding to the payment date. So the payment date will be the end of the period, so that will be Ti plus 1. So in total, this is the present value of the fixed leg as a sum of discounted payments, and each of the payments are made up of a fixed rate times a notional times a coverage for that period. Similarly, we can construct the present value of the floating leg, let's say at time t. Well, for that we're also gonna sum up a number of payments, and let's for simplicity assume that we have an equal number of payments on the fixed leg and the floating leg, which actually is not the case in practice, but it makes things a little bit simpler now. So now we will use the coverage of the floating leg. And if we have a notional structure, we'll scale each of the payments by the notional. So now we'll need to look at not a fixed rate, but the current forward LIBOR rate for the period between Ti and Ti plus 1. And we need to discount it back all the way to small t, based on the payment at ti plus 1. Remember that we stated earlier on that the value of receiving a future LIBOR fixing, even in the modern setup, is just essentially the current forward LIBOR rate discounted back from the payment date till today. The only new thing we have introduced here, and for the fixed leg, is the possibility to have different notionals period by period. So these two numbers are just the values of the two legs in the plain vanilla swap. So one question we could now ask is, what if we added 1 basis point to the fixed leg? Or we could ask, what if we added 1 basis point to each of the forward LIBOR rates? What would the incremental value be of that? For the fixed leg, we realized that the incremental value is actually quite easy to figure out. We could just remove the k and insert just a single basis point. We could call that number the basis point value of the fixed leg at t, and observing that we can just remove the k and still take the sum from 0 up to n minus 1, keeping the coverage, keeping the notional structure, taking the discount factor corresponding to the payment. So in fact, this is actually the value of 10,000 basis points, which is 100%. So to get the value of 1 basis point, we would need to divide by 10,000. But let's keep it as it is for now. We could do the same trick for the floating leg. Adding 1 basis point again can be the same as removing all the forward LIBOR rates, inserting a basis points, so we could equally well construct the basis point value of the floating leg as the sum of all the coverages times the notionals discounted back till today. So what is the difference between the two? Well, we assume for simplicity that they had the same number of payments. That may not always be the case. The frequency can be different. So in practice, we often have annual payments, so a coverage close to 1 for the fixed leg. And for the floating payments, at least in euros, we have semi-annual payments, so the coverage would be closer to a half. We also learned on the previous presentations that the fixed leg had 3360, the floating leg had Act 360. In general, the notional schedules would follow along the same. But these 4 numbers, as we'll show shortly, are the 4 essential numbers to understand most of swap valuation and determination of swap rates and other stuff. We'll see shortly.